We have discussed matrix games in the previous module, and we have discussed two examples. Here are those matrix representation of those matrix games. And in this short module, we are going to discuss about what is the relationship between this max-min, min-max values and that of PSNE. So we'll essentially answer an existential question. So we have just noticed in the previous module that the min-max value for the game on the left, this goalkeeper and shooter game, so there the min-max value is 1, while the max-min value, that is the lower bar, is -1. And we have also seen that in this game the PSNE does not exist. While for the other game, that arbitrary 2% zero-sum game, we have seen that the max-min and the min-max values are both equal to 1. And in this case, the PSNE exists. So perhaps you are already starting to notice what is happening here. And you can also check with more examples to be sure. But let me tell you that the equality of this max-min and the min-max is essentially necessary and sufficient for existence of PSNE in the matrix games. And that is the result that we are going to prove formally here. So for this theorem, let us define the max-min and the min-max values, which are S1 star and S2 star respectively. Now the theorem tells that a matrix game U has a PSNE which is equivalent to a saddle point that we have proved in the previous lesson. So it happens if and only if these two values, the min-max and the max-min values, are equal and is equal to the utility of S1 star, S2 star, where this S1 star and S2 star are the max-min and the min-max strategies for players 1 and 2 respectively. This theorem states that S1 star and S2 star is a PSNE. The proof is not at all difficult, even though it's a little long. So let us divide it into two parts. In the first part, we'll start with the PSNE and we'll show that this V upper bar and V lower bar are actually equal, and that is also equal to the utility at this S1 star and S2 star. So let's say we are overloading the notation here a little bit. If you like, you can use a different notation instead of S1 star, S2 star. Maybe use tilde or something else. So because this is a PSNE, then this inequality must hold. This is the definition of PSNE, and this should hold for all S1 in capital S1. Now since this holds for all S1 in capital S1, then you can also take the max on the right hand side. It is satisfied for all S1, so it should also get satisfied for the maximum of it. So that gives you this inequality here. And now we are again using the standard technique of using the definition of minima. So because S2 star is a very specific strategy, if you take the minima, it will always be greater than or equal to. So this inequality also holds. And now if you look at this value, this is the min-max value, which is the same as V upper bar. Now you can apply the same technique for player 2 as well. For player 2, the utilities, the expression of the utilities or the inequalities will be reversed, and you will find that this V lower bar, which is the max-min value, will be greater than or equal to this value, U of S1 star, S2 star. Now you can stitch together these two inequalities. What you get? You get this inequality which we proved in the first part. We proved this one, and this inequality was given by the previous lemma, the lemma that we proved in the previous module. Now you see that the leftmost expression and the rightmost expression are the same, and these two numbers are sandwiched in between. So therefore it must be true that all these numbers are equal. You have this U of S1 star, which is equal to V upper bar equal to V lower bar. And that is that we wanted to prove in this forward direction. It also implies that this max-min value for 1 and the min-max value for 2 are S1 star and S2 star respectively. So good. So we are done with the forward direction. Now let's prove the reverse direction. So in this case, we are given this this equality. So all these things are same, and let's say that this v upper bar and v lower bar are actually equal to v, denoting by a different notation. And what we are given is that S1 star and S2 star are the max min and min max values for 1 and 2. Now again we will use some techniques of this minimum. So if you just consider that u of S1 star comma S2, where S2 is some arbitrary strategy for player 2, this must be greater than or equal to the minimum. So you are just picking one specific strategy, and it must be greater than or equal to the minimum if you take the minimum over the second component of this utility expression. And now we can apply the definition that this S1 star is actually the max min. So it is maximizing the minimum. So therefore, if you plug that value in, S1 star in, it is actually equal to the maxima, the max min value of this utility. Right? So this is, think through it a little more carefully. You can see that this the definition actually follows this equality. And this max min value is the same as v. Now v is already given as the is equal to the u of S1 star comma S2 star. That is what we are given here, right? So you already get the inequality satisfied for player 1. Now we'll have to prove the same thing for player 2, and you can apply a very similar argument to get that u of S1 comma S2 star is less than or equal to v, and this should hold for all S1. So okay, so just to mention that the previous inequality, we have picked this S2 to be an arbitrary strategy of player 2. So therefore this inequality holds for every S2 in capital S2. And similarly here also you have picked S1 to be arbitrary. So this is the definition of PSNE for player 1, for player 2, because here player 2 is moving from strategy S2 star to S2, and this inequality is going to hold. Consider that for player 2 the utility is actually the negative of it. While for player 1, if you again, this value is actually equal to this one. So if player 1 is moving from S1 star to S1, which is an arbitrary strategy, he is not gaining. So that is the definition of PSNE. So essentially we are done. We have started with S1 star and S2 star, which are max min and min max strategies, and we have shown that, that the same strategy pair is essentially the PSNE of this game.